Hi again, Methods students. Yet another example of solving a trig equation here. This is from an exam one, and these sorts of questions are really common on exam ones. Examiners often want to be able to tell whether you can solve trig equations without the help of a calculator. So let's get stuck into it. Pretty similar to the previous ones we've done. We've got cos of an angle equals a half. Given a domain here that we have to pay attention to know where our solutions, our final solutions can kind of exist. But our first step is to go, okay, well, we have cos of angle equals a half. So what is our first quadrant angle, or what is our base angle? And if we draw the triangle that's got 1 and 2 in it, and we think of 1 as being the, adjacent, because it's cos, and obviously 2 being the hypotenuse, then that tells me that if this side's the adjacent, this must be my angle, and I know from this triangle that the angle down there is pi on 3. So my first quadrant angle, or my base angle, is pi on 3. Remember, this may not be actually a solution, but it's the thing we're going to use to find out solutions. The equation is cos of something equals positive number. So when we look at our 4 quadrants and we're trying to find the quadrants where cos is positive, well, that's in the first and in the fourth. In the first quadrant, well, the angle already is pi on 3. So the angle in this question is 3x on 2. 3x on 2 equals pi on 3. Doing a bit of cross multiplying, we can multiply both sides by 2 and multiply both sides by 3. We get 9x equals 2 pi. And therefore x equals 2 pi over 9. So that was our first, from the first quadrant. From the fourth quadrant, we can say, well, the angle is equal to 2 pi minus the base angle. So in other words, 3x on 2 is equal to 2 pi minus pi on 3. And so 3x on 2 is equal to, well, let's think about this. 6 pi on 3 minus pi on 3, that should give us 5 pi on 3. Again, we can do some cross multiplying. We get 9x equals 10 pi, and therefore x equals 10 pi over 9. All right. Last bit is to use the domain and use the period to see if we can work out where further solutions are. Going back to the initial question, the domain is negative pi on 2 to pi on 2. All right, so that's our domain. It might be helpful to write that over 9, given that these two values are already over 9. So that would be, and we don't normally do this, but just purely for the purposes of comparing, I'm going to write pi on 2 as 4.5 pi on 9, right? Usually decimals within fractions is a bit of a no-no, but we're just doing it to help make some comparisons and evaluate whether our numbers are inside the domain or not. So straight away, 2 pi on 9, yep, that's in this domain. It's between those two values. 10 pi on 9 is not, right? So that's not going to be one of our final answers, but we might need it to find other answers. And the period here, we know it's always 2 pi over n. In this question, that's 2 pi over 3 on 2. So 2 pi divided by 3 on 2, which is really 2 pi times 2 on 3. And our period then is, that's 4 pi. Oh, made a real mess of that. It's 4 pi over 3. Right, so the period's 4 pi over 3, or if we want to make that over 9, it's going to be 12 pi over 9. All right, so this is the value that we will add or subtract to our existing solutions to see if we can generate more solutions. So let's do that. Our first solution was 2 pi over 9. Now, if we do 2 pi over 9 plus 12 pi over 9, we're going to get 14 pi over 9, and that's much bigger than the top end of our domain. So I'm not even going to bother trying to do that, but what I might do is see if I can subtract it. So 2 pi over 9 minus 12 pi over 9. Again, maybe let's do that in our head. 2 pi minus 12 pi, that gives me negative 10 pi over 9. Actually, that's going to be outside the domain as well. So, not getting anything further from this solution, let's try 10 pi over 9. Now that was already too high, so we won't add the period, but let's try subtracting the period from that. 10 pi over 9 minus 12 pi over 9 is going to give me negative 2 pi over 9, and that is inside the domain. So let's try that. It was x equals 10 pi over 9 minus the period, which is 12 pi over 9, and that gives me negative 2 pi over 9. So the two solutions that are actually inside the domain are these two, x equals negative 2 pi on 9 and x equals 2 pi on 9. And so I'm going to write, again, just to be clear, I'm going to write my final answer like this, just to show anyone who's looking at my working what my answers are, and importantly as well what my answers aren't. It's important to kind of be clear that this one wasn't part of our solution.